back to our code and see what else we can add to this linked list. And also we have to test it. Let's first test whatever we have. So also let's also look at the print method. I did the print method last time. We didn't talk about it. So in the print method, I have to kind of use the similar concepts that we did here, right? I have to start from the beginning, the very first node, and I have to keep going until we get to the basic end of this list. And then as we go, we have to print the elements basically out. So I call it this one a pointer. It's starting from the very first node. And of course, if the list is empty, I'm just going to have to traverse it really. It is empty. But if it's not, then I'm going to keep going. I just added some stuff into it to just make it like more readable. So that's going to be the basically like a placeholder for each of those elements to know where if it's empty or not. And so if it's if the pointer is not null, because we're starting, and keep that in mind, we're starting from the first one, and if the pointer is null, that means my list is already empty. But if it's not, then we're gonna, and we know at least this is not the case because we checked this, it's not empty. So we know at least we have one, and then we're going to print that print the element of that one, that basically place or that node. And then we have to traverse, and in order to traverse in the linked list, again, that's very simple. You just have to tell the basically your node that now you have to be the next node, and that's it's easy because you already know who is the next. So I have to only say pointer dot next, and then I assign it or I copy it into my pointer. Now my pointer is going to be the next element. I moved one element ahead. So now I'm going to go check the next elements, and I keep going until the pointer is pointing to the null. And that means if the pointer is pointing to the null, that means we are get to the very end of the list, so I don't have anything else. Yes.
If for some reason you were to have something similar to this where you're going through the entire list, but after you got the pointer.next, you called the remove first function, would that still be of order n? Or so basically, as you're going through the list, you're printing out the thing, then you're removing it from the linked list and going to the next one. Would that still be of order n?
So again, the worst case scenario is still order of n because you still have n element in the list, right? But
well, I'm asking would adding the remove change any the
but if I keep doing it, I'm reducing the size, right? So you basically keep removing the very first one until it gets, so you become empty. So that's not what we want, right? We want to only remove the last one only from the list. We don't want to remove the entire list.
I mean, like for printing, instead of it's print and erase, so it would erase the.
But I'm not erasing anything.
Well, I'm saying.
Oh, okay. Okay.
I made a function called print and erase.
Okay.
And then after I printed out, so after the system.out.println, after pointer.next, I had remove first.
Yeah, that's order of one.
So just still be. You're
basically calling that n times, but it's that method itself is order one because you basically we're going to the remove one, the first, removing the first one, that's always going to be order of one for you. But you have to, in order to go through entire n element to remove all of them, you have to do it n times. So that is still kind of order of n because you have n elements. Yeah, again, back to the same thing. We're actually going to do that in the we have a heap sort algorithm, and you can see that basically, we're kind of doing it. We have to do it n times, and then so we're going to talk about it. But that's going to be the same thing. If you have n element in the list and you keep going to call it, basically the average is still you're going to do this in the order of n. Okay, back to the, so yeah, we know how the print works. So back to the testing. So what we did in the testing, if you remember previously, is that we're creating a class list test, and then we're adding elements into the list. So far we add A and B into the beginning of the list. So now I'm going to add some more to the end of the list. Maybe I'll remove some of them first. So I'm going to remove the first one, which is basically now B should be removed, right? I expected B to be removed because I added those elements at the beginning. So B was my first, and so B has to be removed. Then I'm going to, this is for testing the remove first, and then I'm going to add the remove or add the last. I'm adding C, for example, to the end of the list. And maybe also I add another one to the end. D, for example. And then now I'm going to remove this very last one. So I expected D to be removed. That's my expected result. So now I'm going to print this as well. So if you look at the output, you see that first we added A and B, and since we keep adding things at the beginning of the list, B would now become my first element. Then I remove the first, so B is now removed, and the only element in the list is A. Now I'm adding C and D to the end, so they're going to basically add it in the same order. So my list is now A, C, D. And then now I'm going to call the remove last, which is basically going to remove the D from the list. So my list at this point is going to be A and C only. So any questions so far? Another thing that we like to do usually with our list or collections is basically going to be able to find elements in the list. So the method that we can have is that we're basically giving a particular element and we're trying to search for it basically, right? So that's a search method. We can call it search. What happened to my, okay. So we call it search, and this search method that I have is only going to be a Boolean type. It's telling me if this is inside the list or not. So it's going to get a particular key, and it's now going to check if it's in the list or not. And so imagine also in case of duplication, we're going to say whatever, if we find the very first one, we're going to stop, right? So that's basically our scenario for our search. So since you have to search, same thing, right? So it's a linear search kind of, right? So we have to still doing the same thing as we did previously, even in our print. That means we have to traverse the entire list as well, right? And so if, again, this is a linear search, so we know linear search in the list is always going to be order of n, right? So that's going to give us the same thing because we have to traverse this link. So exactly on the kind of what I had in these two other codes, I need the same thing to do the same thing. So that means I need to have a basically, or a pointer. I'm going to call this one also a pointer. As starting from the first node. And now I have to keep going, right? So again, I'm just, in order to traverse, the best way for me is to using this while. And so I keep checking that if the pointer is not null, and I'm looking for a key, right? So I have to check the pointer.elements has to be equal to this key, right? And so since everything is string, I'm actually going to use the equal method of the string here. So
Wouldn't it never be true? Unless it's the first thing, because
actually I have to say not, right? So if it's not null and it's not the key, then we have to keep going. If it is, then that's basically we find it, right? So this is for us to keep going. And I'm just checking the pointer is not null to making sure that I'm not getting null pointer exception, because if it's null and then I'm trying to get the element of it, it's going to give me a null pointer exception. So we're going to basically keep going. So that means I have to say pointer dot next, right? So keep going to the next element until we find it. So when we're done with this loop, right, either our pointer is null, that means we're getting to the end of the list, right, or we find that element. So it is either one of those things is going to happen. So that's what we have to check. If the pointer is null, I mean, we couldn't find it. We went all the way to the end of the list, and this was not the element that we're looking for it in this list. So that they have to return false. But if the pointer is not null, that means we find it, and so the pointer is no longer empty or null, and so you have to return true. So this is what I'm going to return. I'm going to check if it is not null. If it is not null, true, that's going to return true. If it's not true, then it's going to return false, right? So that means we're either, we find it or not. Let's also test this. Any question?
Shouldn't you add a catch in case the linked list is empty? Because if it's never mind.
Yeah, pointer. That's why I checked that out. So yeah, I'm not going to have that problem because I checked the pointer is not null. I said I'm starting from the beginning. So if the first is null, automatically right there, we're going to get out of this loop. We're not even going inside the loop. And then we're checking if pointer is null, it is, and then we're going to return false. That means it's not in this list. Again, it doesn't matter if list is empty or not. It's going to return not false to us. So search also is also going to take us order of n, right? Because we have to traverse. And in worst case scenario, if you have really an element in the list, and we have to keep going. And if element that we're looking for it is in the end, or even it's not in the list, those are the worst case scenarios, and that's going to take us order of n to figure it out. So we find element in this list. Another thing that's actually, this is an interview question. So it's always, when you go to interview that they want to ask you about the linked list, they always ask you about removing an element from the middle of the linked list, somewhere in the middle, right? So we're going to implement that now together, right? So we find the element, and now we look like to be able to remove it from the list, right? So we remove the first, we remove the last, and we see how this works. But we now have to decide what happens if something is in the middle of this list, and we're trying to remove it. What are the things we have to do, right? So that's a very important, basically, part of the linked list. And again, I usually, when my student going to interview, I ask them, what is the question? If the question is linked list, that means they're, most likely is going to be removed. And usually you get this question a lot, especially if you're applying for internship in the, this year or summer. The linked list is a very important topic for all of the basically companies, I have to say. So what we have to do, we're going to do the same kind of concept we did before. We're going to call it this time only remove. We may ask for a particular element that the user would like to remove it from the list. I'm going to call it the key again. And so we have to see, we have to analyze it together. But of course, what we know for sure is that the list, if we have this search method, we can use it, right? So if it's not even in the list, I can even remove it, right? So that's one of the things I can do. I can first call it my search key. At least I know that it's in the list or not, right? So I don't have to do it when it's not even in the list. So that way I can tell the user that. The element that you're trying to remove, which is this key, not in the list, so I can really remove it. But if the case, if this is true, that means it is in this list. And then so we have to now start thinking about how we're going to find it and what we have to do with it. So there are, let's go back to our whiteboard. So there's different scenarios that can happen. Again, I'm sorry that this keep removing my whiteboard, previous whiteboards. I have to draw it again. So we're going to have our linked list again here. I'm not drawing those arrows anymore because you all know that has an arrow, okay? And so we know this is our first, and this is our last. So now imagine we're basically searching, and then the element that we're trying to remove, it's somewhere here. Like this is going to be the element that we have to remove, right? So it's kind of in the middle of the list. It's not the last, and it's not the first one. So if it's not the last and first, we know it's in the middle of the list. So if it's the first, we already have a method for it, so we can easily remove it. If it's the last, also we have a method for it. We can just call the method and do that. But what if it's in the middle? So if it's in the middle, like I have to do the same concepts, right? So if I want to remove this from the list, I have to just go to its previous one. So imagine this is the previous one. I have to tell the previous one that your next is no longer this node, and actually it's your next node, basically, right? So I have to tell the p dot. Let's write it this way. I have to tell the previous dot next that is going to be the previous dot, the next to that, right? So basically the previous dot next, if you have something like that, right? So obviously I have to know not only this node that I'm trying to remove it, because I have to search for it. That's one thing, right? There's no way I can find it. I have to keep traversing until I find it. So my pointer is going to tell me that this is the one that you're trying to remove. So this is my pointer. It's finding it. It's right here. That's the one that we have to remove it. And then my previous one is, we have to find the previous one too, right? So it's just finding the who I'm going to remove is not enough. I need to know who is the previous of this node as well. So that means when I'm starting to traversing, I need to have two runners instead of one runners. One is going to point to the current node, and the other one is always telling me who's the previous one. So it's going to, basically we keep going as we're have the reference to element always. One that potentially the one that we're trying to remove it, and always we're going to have a copy of who was the previous node, because again we don't have a way to know who is the previous one. If I just go and find the element, and now I have to tell the previous node to ignore it and point to the next of it, since I don't know who is the previous one, I can't really do this job, right? So the only way for me to do it, as I'm searching for this element and I traversing this linked list, I have to have two runners at the same time. One runner is my current, basically the one that we're trying to remove it, and one runner is going to be always pointing to one that is behind it. Make sense?
Could you constitute with just one runner by using the previous dot next?
So we don't like to have that next. That is a bad way to write code, basically, right? So we're kind of talking to strangers. We don't want to do that. So we want to basically have a way to get there. So the best way for us is going to using those two runners always, and so that way it's going to handle it easier. But yes, basically, it's telling the previous dot next. But we have to also make sure that the previous this node also not pointing to anything else, right? Yes. Because we basically have, we don't have, whenever you have this methods that they have to keep calling another method like get x dot get x dot get x and dot get x, at some point one of those may break, and then the entire code is going to crash, right? So we don't want to talk to the other classes that we don't really know for sure what is going to happen to that. So these nodes can change and can, it can break our code. So we're trying to be safe, right? So we're not writing coding this way that we keep having those dot callings, and so we're now having two around it at the same time. It's a safer way to write the code, basically. So that's what we're going to do. That
it's also more,
also readability as well, right? Exactly. So we write always the codes that it's basically easy to understand, easy to read, and also easy to test, and so it's not going to easily crash if something changes in the code. So that's one of the things we're definitely going to ignore. But so basically that's one of the things. So I have to tell the previous dot next to point to this current node that I'm going to find it. Dot next. So this way we basically jump over this node, and so nobody pointing to this node. So some of you may also mention that, okay, so should I change the pointer, so this one also to be null, because now it's pointing to part of our list. It's okay if you do that. In some languages maybe you need to do it, but in Java it's not necessary, because nobody pointing to this node that you're trying to remove it. The only thing that's pointing to it is this one, right? So we're removing this link. so that they know when you're pointing to this, so it's going to automatically be removed from our list by garbage collector. So if there's no point really to add the null to this, node. Again, if you do that, nothing is wrong with it, but we, not necessarily we have to take care of it. Yeah, at least in Java, again, right? So any question? I'm going to start writing a code for it. Is it clear for everyone? So we'll go back to our code. And then we're going to start basically, think about all those scenarios that we have. So first of all, we know that we have to have two runners. I call one of them the previous. They're both starting from the first node at the beginning. And then the other one is the current node. Both are starting from the first, right? So we're starting from there. And then we're going to have our, loop that we had previously. So we're going to go our while loop. So the current node is the one that I'm trying to remove it, right? So that means it's basically similar to search, right? So very similar to the concepts of the search that we had here. That means if element is equal to the key, right? So that's the one that we're trying to remove it. But then the current is always going to point to, sorry, the previous is always going to point to the current, right? So whenever we change the value of the current, right? So it's going to be always the one behind it. So the force is starting from the first, and then we need to do exactly what we did inside our search method. So our current is, again, the one that we're trying to remove it. So if it's not null, and if the value of it is not equal to equals key, that means I have to keep going. And so again, similar to what we did in the search, we have to now tell this is going to be the current dot next, so we can keep going. But the previous one, they always have to point to one that is behind of current. So that means our previous has to point to the current. And I have to do it before this, right? So I have to say previous point to the current first, and then my current is going to change to the next one. So I always have one basically behind my current node as well. Yes. Not really, but again, as to just be clean. Whenever we're calling, part elements or any basically members of our objects, if the object is null, it's going to give us null pointer exception. So we know at least for sure that is in the list. So we're not going to return null, but so we want to be safe. And when we get out of this loop, same scenarios that we had before, it's going to happen, right? So one of the scenarios is that the elements, it can be the very first element that we're trying to remove, right? So basically our current is going to be first, and then first is exactly the key, and our previous also is going to be next. And that means that that the first element that I have in the list, that's the one is going to be removed. So that's one of the scenarios that can happen, right? So if my current is equal to first, I know that I don't need to really do anything because I already took care of it, right? So I took care of all of those inside which method? I can just call it, right? Because I already took care of that. I don't have to analyze and implement that again. Else, if my current is equal to what? Last, I also took care of that one too, right, already. So I don't have to rewrite the code for it. So I'm just going to call the remove. But if it's none of those, that means the class is done. No, sorry. No, let's finish this and then let's go. So that's exactly what we did, right? The previous does next is going to be the current dot Next, and that means this is the element is removed from our list. And for this particular one, we also have to make sure we're maintaining the value of size. In the other two, the remove first and remove last, already going to decrement the value of the size. So I don't have to take care of it again. Only inside this else statement, I have to take care of it. And then also, if you want to tell the user what is this element that you're trying to remove, you can do that because we already know, right? What is the element that we're trying to remove? The key, right? So I just have to use the key value. That's it. So, okay, guys, thank you, and we're gonna see you on Wednesday. Basically the link list is done. Make sure you finish the assignment. The link list is going to be available in the e-learning in the same page of usually, basically. So just submit your code. Make sure you test it, and you know it's working.